In this study, we developed a new mass spectrometer to measure gas phase acids in air. And the way this works is we generate in our instrument acetate ions, and these ions will react very specifically with gas phase acids. And then the ionized molecules we can detect with a mass spectrometer. And what this measurement does for us is it does provide us with a fast response measurements. Within seconds we can see a change in levels of these compounds. One large source of such acids is biomass burning. So we obtained a seed money grant from CIRES to go to the Fire Sciences Laboratory in Missoula, Montana, where you can do controlled fires in the laboratory and study them. And we took our mass spectrometer there to measure what we thought was going to be mostly organic acids. But one of the main surprises in this work was that we found a very, very large signal due to isocyanic acid. The molecular formula is HNCO, so it contains hydrogen, nitrogen, carbon, and oxygen. And it's the simplest molecule that contains all those four atoms. And it's a molecule that's difficult to measure, so it has been measured a lot, and certainly not in the atmosphere. On Labor Day of 2010, a very large wildfire broke out just behind Boulder. This was called the 4 Mile Canyon Fire. So here you have this world-class atmospheric chemistry laboratory exposed to a wildfire, and many researchers in our lab turned on their instruments to measure these emissions. And we also did this with this new instrument because it gave us an opportunity to measure isocyanic acid in a real fire, not just in a laboratory setting, but in a real fire. And it was very interesting for us to see that we saw the exact same levels relative to other trace gases that we had observed in the Fire Sciences lab. Our research showed that if isocyanic acid is present at 1 part per billion in the air that we breathe in, it will dissolve in your body and give rise to levels in your blood that are probably harmful to you. So then the question was, where are people exposed likely to 1 ppb of isocyanic acid? Now, if you were to work very close to a wildfire, you would probably be exposed to those levels. Miles away, where we were downwind from the 4 Mile Canyon fire, we were not exposed to those high levels. We were somewhat below it. And other places where you may be exposed to these kinds of levels are, for example, indoor cooking fires, which are quite common in developing countries. And from measurements in those kinds of places of other trace gases, we would definitely expect isocyanic acid to be present at harmful levels.